6.1 Accumulation of change. So the area between a function and the x-axis is called the area underneath the curve. Under does not mean the same as below. It just means between the curve and the x-axis. So for example, if we want the region under this curve here, see the x-axis is right there. So the region between under the curve is just the region between the curve and the x-axis, all this here in blue. In this case, it's below the curve. However, in this function here, you see the x-axis is up here and the curve is down here. So the region under the curve is actually going to be above. Again, just think about this as the region between the x-axis and the curve, not literally below the curve every time. And this last one here, some parts you can see are going to be above, some parts are going to be below the curve. It depends on what function you're given here. So let's take our rate of change function and examine its graph. The area underneath the curve gives us the accumulation of change. So a problem here, you're on a road trip and have your car on cruise control for 4 hours. You travel at 60 miles per hour. How far have you traveled? So you can see here we have, from this problem you can probably easily tell, just 4 times 60, right? But if you're looking at a graph, you can think about, so you have a graph here of the rate. You can see it's miles per hour, that's the rate. If you take an integral of a rate, so from 0 to 4, we take the integral, which is the area underneath the curve of the rate, that gives you the total amount, the accumulation of change. So you see this is a rectangle, the length here is 60, the width is 4, so it's 60 miles per hour multiplied by 4 hours. The hours cancel out, and you're left with 240 miles. Again, when you take the integral or the area but underneath the curve of a rate, which was miles per hour in this case, it gives you the total amount in this case, which is just miles traveled. So the units for the area underneath the curve is just the dependent multiplied by the independent unit, similar to what we did up here. The unit for y times the unit for x. In this example, the unit for y was miles per hour. We multiplied by the unit for x, which is hours. The hours cancel out, and your final unit was just the miles. This next example here, the graph below represents the rate at which water is leaking out of a tank. The units are given in the graph, how much water has leaked out of the tank after 9 minutes. So, same thing, we just want to find the area beneath the curve here, from 0 to 9. So the way you do this is, it's a kind of weird shape, right? Not just like a simple rectangle like the one before. However, we can make this shape into something nicer, break this up into nicer shapes. So for example, if I draw it like that, this is a rectangle, a semicircle, and a triangle. The area of this rectangle is 2 times 6, which is 12. Now, the area of this triangle is 1/2 base times height, if you guys remember. The base is 1, 2, 3, the height's 2. 3 times 2 is 6. 1/2 of that, it's 3. So the area of this triangle is 3. 1/2 times base times height. So now this is a semicircle, a half circle. The area of a circle is pi r squared, but if it's a half circle, you also divide it by 2. So this is the middle of the semicircle. The radius is the distance from the center to the outside, in this case, which is 2. So this is just pi times 2 squared, which is 4 pi over 2. Sorry, that's a 4 pi. Look like a 9, but this is a pi times 4 over 2. 4 pi over 2, this here is just 2 pi then. Because 4 divided by 2 is 2, and you leave the pi. So the answer here is just 12 plus 3 plus 2 pi, or 15 plus 2 pi. And the unit here is gallons, because gallons per minute times minute, the minutes will cancel out and you're just left with the gallons. This final example here, a particle is moving along the x-axis at a rate modeled by r of t and shown in the graph below. How far is the particle from its starting position when t equals 0 after 10 seconds? So you can see in this curve there are some positive areas where it's above the x-axis and some areas below the x-axis and then above. Um, Anything that's above the x-axis, so you can think about it as moving to the right, or up or to the right, and then any area below the x-axis represents the particle moving to the left. So we can find all these areas here first. This triangle up here, that's 10 times 2 divided by 2. That's a positive 10. You can break this part down here into a triangle, a rectangle, and then another triangle. So this triangle right here is 1/2 base times height. So base is 1, 2, 3. Height is 15. 3 times 15 is 45. Divided by 2. That's 22.5. Even though this area is underneath the curve, I'm going to keep it as a positive for now. It just means 22.5 to the left, even though you could think about it as a negative. This rectangle here, this is just length times width. 2 times 15, which is 30. This this triangle right here is 1 times 15 divided by 2, which is 7.5. And then this triangle right here is 2 times 10 divided by 2, which is 10. So how far is the particle from its starting position after 10 seconds? You take all the areas above and you subtract the areas below. So 10 minus 22.5 minus 30 minus 7.5. And then you add the 10 up that's above the x-axis. If you put that all on the calculator, you get an answer of negative 40. And that just represents, in the context of the problem, negative 40 means 40 centimeters to the left. So how far is the particle from its position at t is equal to after 8 seconds? So what you're looking at here now is just from t is equal to 2 to t is equal to 8. This is your starting point. You look at the area from t equals 2 to t equals 8. So all you do is, let's see, you can take this is the negative 22.5 minus the 30 minus the 7.5, because that's all the area we have from 2 to 8, and that's all a negative area. And that gives you a negative 60. So that means you're going left 60 centimeters. Again, we know the unit here is centimeters because we have centimeters per second times seconds, and that gives us just centimeters. You can go ahead and start the practice.